In this video, we're going to talk about trig functions or real numbers. Actually, we're going to define 6 trig functions and we're going to prove a theorem. The sine of x, which is always abbreviated by Sin of x, this is equal to the opposite side over the hypotenuse. If you have a right triangle, what's opposite the right angle is the hypotenuse, and let's talk about that angle, thus opposite it. And adjacent means next to, but not the hypotenuse. So this side is the adjacent. The opposite and the adjacent depend upon which angle we're talking about. We're talking about this angle. Well, that's the opposite. This is the right angle. Adjacent to this angle is either this side or it's that side. But opposite the right angle is always the hypotenuse. So it's the other adjacent side that we call the adjacent side. Now, the next trig function is the cosine function. The cosine of x, which is abbreviated Cos of x, is the adjacent side divided by the hypotenuse. The tangent of x, which is abbreviated tan of x, by definition is the opposite of the angle x divided by the adjacent angle to x. The next one that I will define is the secant of x, which is abbreviated Sec of x. And it is the reciprocal of cosine. That is, I took cosine and I flipped it over. The cosecant of x, which is abbreviated CSC of x, this is the reciprocal of sine, which is the hypotenuse divided by the opposite. The next and last function is the cotangent of x, which is abbreviated COT of x. This is the reciprocal of tangent. So it is the adjacent over the opposite. Adjacent over the opposite. Now, I want to move the top one over because I need the space. There is this saying, to spell it correctly, soccer tower. Let me write it down here. What does soccer tower tell us? It tells us that the sine is equal to opposite over hypotenuse, that the cosine is adjacent over hypotenuse, and that the tangent is opposite over adjacent. SOH, which is exactly what it says here, CAH, which is what it says here, and TOA, which is what it says here, SOHCAHTOA. Now, let us look at this. Sine and cosine, they start with S and C. And secant and cosecant, they also start with S and C. One would hope that the reciprocal of sine would start with the S, but it doesn't. It's the other letter. You have S and C, sine and cosine. The reciprocal of sine, it starts with C. The reciprocal of cosine doesn't start with C, starts with S. The reciprocal of sine starts with C, which is cosecant, and the reciprocal of cosine starts with S. And tangent and cotangent, they have the name tangent in both of them. It's easier to remember that those are reciprocals. Okay. Now, we will prove a couple of theorems actually. If you have the sine of x divided by the cosine of x, well, sine of x is opposite over hypotenuse divided by the cosine of x is adjacent over hypotenuse. I hope you realize that hypotenuse cancel out, because if I multiply the top by hypotenuse and the denominator by hypotenuse, they cancel out. And all I did was multiply by 1. And what I get is opposite over adjacent. Oh, but that's the tangent of x. Yes, the tangent of x is sine x over cosine x. For example, if the tangent button broke on your calculator and you needed to find tangent of 60 degrees, don't worry. Just calculate sine of 60 degrees over cosine of 60 degrees, and you will get the correct answer. Okay. Now, let's prove this very important theorem. Suppose you have a circle of radius r. That is x squared plus y squared is equal to r squared. Now, let's take any angle. Let's take any angle t. Now, the sine of t, we can make our right triangle. Remember, the hypotenuse is r. So, the sine of t is, now one last thing, this point here is some xy. That is, that's x, and this distance is y. So the sine of t is the opposite over, that should be r, I apologize, the opposite over the hypotenuse. And the cosine of t, it's the adjacent over the hypotenuse. Well, multiplying both equations by r, we get that r sine t is y. R cosine t is x. That's exactly what we get. Now, what happens if we square both sides of both equations? The first equation we'll get r squared sine squared t equals to y squared. And on the second equation, I get r squared cosine squared t is equal to x squared. Now I'm going to add them. When I add the left-hand side, they both have an r squared. So I can factor it out. You get r squared times sine squared t plus cosine squared t. And when I add the right side, I get r squared, because x squared plus y squared is r squared. I did say that. Okay. So we have r squared is equal to r squared times something. And you tell me what you multiply r squared by to get r squared. The answer is 1. So sine squared t plus cosine squared t is 1. This is always, always true. So if somebody asks you what the sine squared of 18 degrees is plus the cosine squared of 18 degrees, do not waste your time and go and look for your calculator. The answer is 1. No matter, as long as the t's are the same, and you take sine squared of that angle plus cosine squared of the same angle, you're gonna get 1. Now, while we're at it, so I advise you to remember that formula. The next two formulas, I've never remembered. I derive them each and every time I need them. How about we divide everything by cosine squared t? This first fraction, well, remember that a squared over b squared is a over b, whatever that is, squared. So here we have sine t over cosine t, which is tangent t squared, plus, that's 1. And 1 over cosine, that starts with c, we're going to get the secant of t squared. That's one formula. I never remember which side gets the 1, but I derive it. On this side, we're going to divide by sine squared t. Well, this fraction, I hope, is obvious. It's 1. This is cosine t over sine t, which is cotangent t squared. 1 over sine. Well, sine starts with s, so we're going to get cosecant squared t. Remember, this is 1 over sine t times another 1 over sine t. And each of those sine t's are cosecant t's. And when you multiply it by itself 2 times, get cosecant squared t. And this is another formula that you're going to use from time to time. Okay, this completes the video on definition of trig functions.